good evening, good afternoon, and good morning, depending where you are. It's about electronics. I am a young electronic guy. I love electronics. I am into instrumentations. Can use any tools like oscilloscope, multimeter, analog meters for measurement and calibrations. I am into maintenance. I can repair any appliances, household appliances, digital mixers for sound systems, speakers, anything. I love electronics, you understand, but I also likes to share my experience, and I also stand to be corrected because it is what made me. Professional correct me, you understand. But today I'm going to share with everyone the little things that you understand about voltage, current, and resistance. Voltage is a force, it's an electrical force. Current is the net unidirectional movement of electrons, of charge, electrical charge in the circuit. Circuit is a material selected to pass current. A selected material because conductor is any material at all. Any material at all is conductor. So it could be human being. Human being is a conductor of electricity because there is liquid inside. There is liquid in our body. So human body is a conductor of electricity. So we cannot say human body is a circuit. Circuit is material selected for the passage of current. Cable is a circuit. Wire is a circuit. We have circuit board where there are lines of connection. Do you understand? So, and every circuit has an inbuilt resistance, inherent resistance. The same thing if you are moving on the road, it is actually the friction on the ground that keeps your movement. That friction is resistance. And when you move a very long distance, you will lose a lot of energy because of the friction on your leg. Because if the ground is very smooth, there won't be movement. It is actually the friction, the resistance is what holds your leg for you to move the next step. So it is the resistance that makes you tired when you're moving on the road. So the driver, the car, and the road. The driver go is the voltage, is the one that triggers car, is the one that sets car in motion. The car itself is the current. It is the movement of something that has 4 tires on the road. And be car. The road has resistance, is a part, is a circuit where motor runs. So cable is a circuit where current flows. Current is actually that charge, that electrical charge. Do you understand? And anytime current moves along a circuit, whatever is connected on that part determines the behavior of the current. Anything connected on the path of current determines the behavior of the current. For example, if an inductor is connected on the path of current, it will change the current behavior. This is how it's going to change it. It will make the current to delay. Why is that? Inductor has to do with coiling of wire. Coil wire many times. So the current will begin to run around. Cable go the patrol, they run until complete all the whole turns. If you turn the cable 1,000 times, current is going to run 1,000 times marathon until it comes out of the terminal. For wire, if you are coiling a wire, just one single wire, you coil it many times, the two sides will come out like this. So inductor now, it slows the movement of current because the current has a long way to run before it comes out of the second terminal. So in that case, they supply current and then the load current. The supply current, there's actually current coming from utility, the one where you connect your socket, the one you coming from calling supply current. As you enter that circuit, and it is because current that you supply to circuit will run around inside the circuit and come out. Because for voltage, you have the peak and the true. whatever that goes up in electric current must come down. As it's going up, it is the input. As it's coming down, it is the output. So the output side must be equal to input side in terms of time. So if it is going inside and it delays, when it come out, the time will change. That's the reason why you discover if they come out capacitor for inside fan, they work again. Because the supply current and then the what is it called? The supply current and then the load current are not in the same time. They've changed time. And then the time sometimes is completely out of phase. They are no longer, they are like 180 degree or out of phase. In that case, they'll cancel each other. Nothing will happen. You go hear inside fan. The right put capacitor is that capacitor that actually corrects that time delay. Because capacitor charges very fast, like 1/1 million of a charge of a time. As in, it is so fast to charge, like 1/1 million. So it will hasten the load current to meet up with the supplied current. That's the reason why if capacitor is out of your generator, it no go supply. If it's out of your fan, out of your AC, it no go work. Because the inductance, that thing that is making your AC to roll. Now coil of wire, the coil many times, can't carry magnetic material put in between. So whenever you supply a current, it go begin to turn, begin to parabolate until all the turns where you turn before it go come out. Before it go come out, you no go meet up with the supply current. Number 2, energy don't lose. As it begin to turn, if you turn am 1 million times, current go turn 1 into 1 million times. Energy don't lose. It's like you running from Ikorodu to Yaba. Before you reach Yaba self, you go need to pour you water. So you understand? You go need cold water. Now be capacitor. That cold capacitor go call like cold water. We go boost the energy of the supply current, make it meet up with the energy of the load current, make it meet up with the supply current. So if you supply a current through a circuit, if it meets inductor, it will cause the voltage to delay, and that is what they call inductive reactance. Inductive reactance is a situation where the coil of wire delays the supplied current, and then the supply current lost a lot of energy due to the resistance on the coil. So the current will delay because you have many distance to run. It go delay, no go meet up with the supply current. That's why they call it inductive reactance. Inductive reactance slows down the movement of current. That's what I'm telling you. As current they move, anything where you encounter will determine what happen to that current. If you encounter inductor, it slows down the movement of current. If you encounter capacitor, which is capacitive reactance now, if you encounter capacitor during the course of its movement, it will hasten the movement. In that case, current will lead voltage. But in the case of inductor, voltage will lead current. All of them must move at the same pace. None of them should lead each other. Current must not lead voltage. Voltage must not lead current. Do you understand? So in the case of inductive reactance, the system causes voltage to lead the current, which is not good. Then in the case of capacitive reactance, the current rushes. Like I told you, capacitor takes 1/1 million of a time to charge. So bam, it don't charge. It go run ahead of voltage. It is good in a way, but current and voltage must be at the same pace. The speed must be the same. Because driver running ahead of motor, you know the inside motor again. Or motor running ahead of the driver, now him be say brake don't fail. If you encounter resistive load, maybe like hot plate, maybe like resistor, maybe like electric iron, what happens is that resistor or resistive load reduces the magnitude of current. It reduces the magnitude of current, the size of current will drop. The electrical energy will be wasted to heat. Do you understand? The other one causes voltage or current to delay. Capacitive reactance causes current to rush. Then resistor reduces the size of current. That is the update for today. Capacitive reactance, inductive reactance, resistance.